All right, today we're going to talk about how to graph equations on a number line. So if you look right here, it wants us to graph the solution to x plus 4 equals 9. Well, think about what number you know. What number plus 4 equals 9? And that number is going to be 5, right? 5 plus 4 equals 9. So x is equal to 5. And how you do that on a number line is you literally just put a dot, a closed dot, on the number 5. And it is important that it's a closed dot, and we're going to talk about why in about a week or so. But just know for now it has to be a closed dot on the number line. Now for the next one, graph the solution to 3x equals 18. So we're looking at x, and we're thinking 3 times what number equals 18? That number is going to be 6. So 3 times 6 equals 18. So x equals 6. So then when we go down to our number line, again, we just want a closed dot on the number 6. Right there, just like that. And that's it. That is how you graph equations. So hopefully you have a good hang of it now. With those two examples, I hope you can see that it's pretty easy to do. And now we're going to talk about writing equations. And I just want us to look at this and know that this part right here where it says x plus 5. X plus 5. This is the part known as the expression. And when you add the whole thing all together, so when you have x plus 5 equals 20, when you have this whole thing here, that's called the equation. An equation, like we've talked about before, has an equal sign. So you can see that in the word right there, equation kind of looks like the word equal, which is good because we have an equal sign in an equation. So when you're writing equations from a scenario, like from scratch, you might get something like this, where it says 6 less than a number is 2. And we're going to look at this word is, and that is always going to be our equal sign. And then we're going to figure out what comes before that. So 6 less than a number. So if we have a number and we subtract 6, that's going to equal 2. 6 less than a number is 2. And you can pretend that n is anything you want. So you can pretend that n is, actually you can't. This is an equation. I'm sorry. All right, so forget I just said that. N minus 6 equals 2. 6 less than a number is 2. Can you figure out what that number is? We don't have to, but you can. Yeah, it would be 8. So n would be 8 in this case, but we don't have to do that. Anyways, okay, I'm really digressing here. Let's go on. So for the next one, we're looking at 4 times a number is 8. So 4 times a number, and is our equal sign, is 8. I think that we could write this a little bit better in algebraic language. This would be 4n equals 8. Because even though the 4 and the n don't have that multiplication sign in between them, whenever a number and a variable are touching, that means multiplication. So 4n equals 8. These are saying the same thing, but this one is just a little bit more fancy. All right, let's look at the next one. We have got 5 and a number. What do you think the word and means in this situation? Is it going to be adding, subtracting, multiplying, or dividing? If you said adding, you're correct. 5 and a number, and then is our equal sign, 17. Again, we don't have to solve these. I know that you can solve them in your head, but we don't have to. We're just writing them. This is called writing basic equations. so we don't have to solve them. And then for our last one, we have a number divided by 4 is 3. So a number divided by 4 is 3. And again, you can write this in a fancier algebra way and write n divided by 4 is 3. They are saying, these two things are saying the exact same thing. The one on the right is just a little fancier. We like to be fancy in algebra. All right, so let's move on to the next side. So this side says, you can write an equation to represent conditions within a real-world problem. And it's important to remember that the variable should be located within the expression part of an equation. That's not always true, but it's usually true that the variable, the x, is going to be, let me see what the example was right here. So the variable is going to be in this expression side of the equation. So our x is going to be over here and then not over here. That's what it's trying to tell us. So on x plus 5 equals 20, x plus 5 equals 20. This is saying that the variable should be located within the expression. And is our variable located in our expression part over here? Yes, it is. All right, so that's just normally what's going to happen. So when we get down here to these word problems, that is just a helpful hint for you to have you help set up the word problems. So we have little scenarios here, and I'm going to give you a hint. It starts out with addition. This one is subtraction. This one is multiplication, and this one is division. So as we go down, hopefully you'll see that this is one example of each type that you might see. So here we have an orange and a cup of juice are 210 calories. And R is another word for the word is. It means equal. So we have an orange and means plus a cup of juice equals 210 calories. An orange has 90 calories. And it wants to know how many calories does juice have. This is what we don't know. So the way that we can set this up as a equation is 90 plus, I'm going to say J as my variable, equals 210. And that's it. So we would have this as our equation, and that's all we're trying to do is write the equation. On the next one, oh, well, do we want to solve it? Let's see. We totally can solve it. Let's just solve it just because we can. So do you know what 90 plus what number equals 210? I actually don't know off the top of my head, so I'm going to have to do some subtraction over here to see if I can figure this out. 11. So 11 minus 9 is 2. So I think J is going to be 120. So 90 plus 120 would equal 210. 120 plus 90. It sure does. So that's how you could solve it, but we don't really have to for this. We're just writing the equation. But that's how you could figure out how much juice, how many calories were in the juice. For this next one, let's change colors. Lake Arrowhead State Park has 3 less hiking trails than Irwin. 3 less than Irwin. So we have Irwin minus 3 equals Arrowhead. Arrowhead has 5 hiking trails. So if I write this like this, I can say E minus 3 equals 5. How many does Irwin have? Well, Irwin would have 8 hiking trails, because 8 minus 3 would equal 5. So if we had to figure it out, that would be it. But the most important part of this is actually getting the equation written correctly. So there we go. All right, let's do the next one. 7 tickets to the Children's Museum cost $35. So if I have 7, it says how much does one ticket cost? So if I have 7 tickets, my cost is going to be $35. Well, how do I know what one ticket costs? So 7 tickets, maybe it should be times the price of one ticket equals $35. So 7 times the price of a ticket equals $35. So you could do, in fancy algebra terms, 7p equals 35. So just based on that, can you figure out how much one ticket costs? Here, let's highlight it. Can you figure out how much one ticket costs? 7 times something equals 35. That's right. Each ticket is $5. All right, and then for our last one, ground beef is being divided into 4 hamburger patties. Each hamburger patty is 6 ounces. How many ounces of beef are there all together? So I have ground beef being divided into 4 patties. So I have beef divided into 4 patties. And each hamburger is 6 ounces. So each of these hamburgers is 6 ounces. And it wants to know how many ounces of beef are there altogether. So this is the thing that I don't know. This is my question mark. So the expression that I would probably write here is beef divided by 4 equals 6. Or you could write B divided by 4 equals 6. So, again, we don't have to solve it, but we could. We know that 24 divided by 4 would be 6. So we're talking about 24 ounces of beef all together. So those are our notes. So you're going to glue those into your journal and add them to your table of contents. And then whenever you're ready and you're done gluing those in and adding them to your table of contents, then you're going to start your practice problems here. Be sure to write your name up here. So the directions say to write an equation using a variable for each problem below. Let n represent the variable in problems 1 through 4. So 1 through 4, my variable is going to be n. So, let's look at doing number 1. Let's do number 1. 7 more than a number is 26. And what do you think the word more means? Addition, subtraction, multiplication, or division? It's addition. So here I have my number, and I want 7 more, and that is going to be 26. That's your answer. That's it right here. That's all you have to do. Cool, huh? So then you're going to have to do 2, 3, and 4 using n as your variable. And then when you get down here to 5, 6, 7, and 8, They have a little bit more lengthy word problems, but I know that you can do them. So let's look at number 5. Fernando and Tim collect baseball cards. Fernando has 125 cards, which is 49 more, we already said last time, more equals addition, cards than Tim. Let Y represent the number of baseball cards that Tim has. So, let's think. 49 more than Tim. So here's how much Tim has, because Tim is Y, and Fernando has 49 more than Tim. And Fernando has 125. So Tim plus 49 equals Fernando. Let's read the problem, the word problem one more time and make sure that our equation that we wrote matches the word problem. Fernando and Tim collect baseball cards. Fernando has 125 cards. That's good, that's what I put. Fernando has 125, which is 49 more than Tim. 49 more, so that's plus 49 than Tim. Let Y represent the number of baseball cards that Tim has, and that's what I did. Y stands for Tim. So I totally did it. We totally did it. So Y plus 49 is 125. That's it. Now I'm going to give you another hint. This one was addition. This one needs to be subtraction. This one needs to be multiplication. And this one is going to be division. So as you're going through, that should help you out. All right? If you have any other questions today, don't hesitate to come ask. Thank you.